Alright. Okay, so pretty much we left the review off on number 18. 18 looks like we're given, we have a shaded region right over here. Alright, so automatically we can tell that we're working with inequalities. So that's an important topic when dealing with this problem. And also system. Alright, since we have two of them. So the question is which defines the system? Now, I'm going to go to the next page just to look at some answers. So we have three choices. So basically what we're going to have to determine is what is the inequality, how is the inequality symbol, and which two inequalities we actually have. So let's go to the other side. Alright, now looking at this problem, I'm going to focus on this line right over here. Alright, it's a solid line. So we generally want these inequalities in slope-intercept form. Now if I look at this, I'm shading right over here. Okay, so even though our solution is this region, I'm shading right over here. So I'm shading below the line. Well, if it's below the line, that means it's going to be less than. Okay, so just to start off, let's put y is less than. Alright, now since it's a solid line, is it just going to be less than, or is it going to be less than or equal to? Well, it's less than or equal to, so I have to put this equal to part because that means we're including that. Okay. Now, when we have to work with this, we have to find the slope, we have to find the y-intercept. Well, looking at this line, we can find both of those. So off to the side, we have m equal to and b equal to. Alright, well let's find our b, which is the y-intercept. If I look at this crosses the y-axis at positive 2. Alright. Well, now we have to find the slope. Now, it looks like it's going to be a positive slope. If I put a dot right over here, we can choose any other point on this line. I'm going to choose this one. Alright. So for slope, we have to figure out how much we're rising and how much we're running. From this point, how much are we rising? Well, it looks like we're rising just 1. How much are we running? It's going to be 2. Alright. Now, it is positive 2 because we're moving to the right. Now looking at this, our rise is 1, our run is 2. So for our slope, I'm going to put 1 over 2. Okay, so the way I write this in slope-intercept form, y equal to mx plus b. Alright, so I'm going to put, so I've already taken account for this y. Let's put m is 1/2, x, and plus b, well b we found was 2. Alright, so we at least know that this line, this inequality that's shaded below, is right over here. Okay, so let's find the next one. This other one I can already see, so let's just put y. Now, if I look at this line, I'm shading over here. Now, is that above or below the line? It looks like it's going to be below, or sorry, above the line. So it's going to, since it is above, it'll be greater than, and it remains only greater than because we have a dashed line. So you keep that. Alright, so now comes the case where we have to find, for this, the m and the b, the slope and the y-intercept. Let's find the y-intercept first. So where this line crosses the y-axis, looks like it's right over here. And looks like that'll be a -3. Now let's deal with finding the slope. You can go up the line, you can go down the line, doesn't really matter, you'll find the slope regardless. I'm going to choose this point right over here. So let's figure out how much we rise. My rise is actually, I'm going down. Alright, so I'm going down 2. Since I'm going down 2, that means it's going to be a -2. And 1 over to the right, so that's positive 1. So setting this up, -2 over 1 can be simplified to just -1. So, having our slope and our y-intercept, let's put this in slope-intercept form. That'll be -2x plus, -3. So if I look at this, alright, we have y is less than or equal to 1 over 2x plus 2. The other one is y is greater than -2x minus 3. Okay, so let's see which one of our choices is that. And it looks like, and it looks like letter C. C is our answer for number 18. Moving on to number 19. Number 19 says, given that the system of two linear equations has no solution, I'm going to underline that, that's important here. Which statement is true about the line's slope and the y-intercept? And basically it's just detailing Are the slopes the same? Are they different? Are the y-intercepts the same or are they different? Well, let's consider for no solution. So for no solution, I'm going to use this whiteboard over here. If I just draw the x-axis and y-axis, what does it mean to have no solution? Well, that means that if you were to graph this, the lines would not intersect. Alright. In other words, they would be parallel. So let me draw a line over here and a line over here. Well, these are two lines that won't intersect. Now, if I were to compare the slopes, they look like they're the same, right? They're inclining, they're rising, and they're running about at the same rate. So I would think that the slopes, so slope is the same. So now comes the case, is the y-intercepts, are they the same? So y-intercept meaning that's the point on the line where it crosses the y-axis. Well, over here, looks like the y-intercept is, for this line, the y-intercept is right over here, probably around, looks like this is around 4 or 5. And over here, this is where the line crosses the y-axis. Now we can visually see that that is not the same point. So the y-intercepts should be different. Okay, they don't intersect the y-axis at the same point, but they do have the same slope. Okay, let's look at our choices here. Which ones could we say are match that? I believe it's letter B. Okay, we look at our other choices. A says the slopes are equal and the y-intercepts are equal. Well, that means that those two equations or lines are the same thing. That would actually define what is infinitely many solutions. Okay, and the last solution being one solution. But that's not what the problem is asking us. Alright, moving on to number 20. Just reading the problem, this looks like it's going to be a geometric sequence or exponential problem. So if I look at this, number 20, the number of bacteria in a dish is initially measured to be A. Okay, so we're not given a number, we're just given a variable. The population grows by 5% per hour, so we're getting a time constraint. Which expression represents the number of bacteria after H hours? Okay, so this definitely sounds like an exponential growth. So first off, let's just write the formula. So we're going to have f of x equal to ab to the x power. Alright, this is just giving us, we've learned this before, this is in our notes. You'll find this probably in section 21. Alright, where this a, right, not associated with this a really, is the initial value. So the initial value. And the b is really the rate of change. Well, looking at this formula compared to this, what do we notice? Alright, I notice that D, the format of D, doesn't quite look like that. A, B, and C, they kind of look like it, right? Now, whenever you have an exponential, you need that variable. In this case, we have x. Well, in this case, we actually have h hours, is in the exponent. Alright, well, let's fill in what the problem gave us using this formula. So, initial value. Well, the problem said that initially is measured to be A. So I'm going to put capital A. Alright. Now, the rate of change, we can tell in this problem, actually it tells us, the second sentence, it says the population grows. So, is this exponential a growth or decay? It tells us that's going to be a growth. Alright. Now, for growth, that means that this term B, it should be greater than 1. Right? If it's greater than 1, if it's 2, 3, or 4, alright, this thing is increasing super fast. Now, since it has to be greater than 1, it's saying it's growing by 5%. Now, I don't see percent in our answer choices, but we can convert percent to a decimal. So if I were to have 5%, decimal is at the end of the number, move it 2 spaces to the left, giving us 5 hundredths. So I'm just going to put that on with an addition to 1. So I'm going to put 1.05. Okay, what this tells me, this is my rate of change. How much is above 100%? It's only 5%. Okay, and the variable that we're using, well, it expressed as hours, as h hours. we're going to put that in our exponent. Alright, so looking at this, A is the correct answer. Okay, it wouldn't be, I kind of anticipated a lot of students might put C. Not quite, because you need the variable as the exponent. In this case, it puts the variable with this one over here inside the parentheses. So you don't want that. Alright, moving on to the next one, number 21. Which shows the inequality ax plus y is less than or equal to z. Solve for z, where a is a non-negative number and b and c are positive integers. That's actually a typo. B and c, it really should just be y, or b and c should be y and z. Okay, but that's not really important in this problem. Now if we look at this, I'm just going to rewrite that inequality. Now it said solve for a. So solving for a meaning I want it, or sorry, solve for x. Alright, so basically when it just says solve, all you need to do is get x by itself. So in this scenario, I want to get rid of a and I want to get rid of y. Now if you want to follow along with your notes, you might want to look at the section titled Literal Equations. Literal equations are just equations that deal only with letters. Okay, well if I want to get rid of x, I have this a that's being multiplied to it, I have this y being added to it. You really want to get rid of the thing that's kind of furthest away, right? You're working with PEMDAS but backwards. So if I look at this, I really want to get rid of y. So getting rid of y, you have to do the inverse of adding y. So I'm going to subtract y to both sides. So we're going to have ax is less than or equal to. Now looking at this z and negative y, they don't really simplify, so you're just going to write what you see. Just like that. And one more step to get x by itself. When letters are next to each other, that means they're being multiplied. So I'm going to do the inverse of that, which is divide. Divide the left hand side and right hand side. So finally we're going to have x is less than or equal to z minus y over a. And that is D. Okay, moving on to the next one. Next one is 22. Now, above it says, for questions 22 through 23, use the linear function described below. Now we have two of them. The first one is expressed as a table. The second one is expressed as an equation. We're usually used to dealing with equations here. Okay, now we can just look at this table. We can find an equation from it. Now, on the top row, I see that we have x. On the bottom, we have f of x. Alright, f of x, like I said before, is just the same as y. So if you want to, you can just write y right next to it. Okay, well, I want to come up with the equation for this in slope-intercept form, y equal to mx plus b. Alright, well, let's find a couple things. Let's find our slope and our y-intercept. Well, our slope is always expressed as rise or run, or you can think of it as how much we're changing with our y compared to how much we're changing with our x. So, do we notice a pattern here? Well, it's increasing. That means I'm going to be adding something. But from 0 to 10 to 20 to 30, it looks like we're increasing by a constant amount of 10. So this over here in the numerator, our slope will be 10 over, let's look at our x's now for our denominator. This is increasing. It's starting with negative 15, going to 0 to 15 to 30. Looks like we're adding a constant amount of 15. Okay, so set it up like that. Well, this is 10 over 15. We can simplify that. 5 goes into both, so we're going to have 2 over 3. That's our slope. Now our y-intercept. Now, I hope you guys remember, whenever you want to find your y-intercept, okay, like wherever it crosses the y-axis, you know what? How about I label these right over here? So this is dealing with the previous problem. This coordinate right over here is 0, positive 5. This coordinate over here looks like it's 0, negative 4. So if you don't remember, if I just look at that, if I note those coordinates, what do they both share? Okay, well, if I write a coordinate, it's always x comma y. They both have that x is the x. Let me erase that. The x is always 0. Remember that. Okay, so if I want to find the y-intercept, x has got to be 0. Well, let me see in our table, where is x 0? Well, x is 0 right over here. Well, what is our y then? Y is just 10. Okay, so since I found my y-intercept, that's where I look at where x is 0. X is 0 right over here, and just looking vertically here at our y column, we can see that the y, or our f of x, is 10. Okay, so using these two information, or these two things that we just found, we can put that in slope-intercept form. So I'm going to write y equal to m in, I'm going to replace m with 2 over 3 x, and our y-intercept, our b, is positive 10. Okay, so I'm going to box this. Now we can actually get to these questions here. For question 22, it's telling me to compare the two things. Now that we've just gotten this table into an equation, I'm dealing with this equation and this equation, where this is our f of x and this is g of x, right? We could just use different letters for it. F of x is just the name of that equation. G of x is also the name of that equation. Let's get to 22. It says the slope, so we're dealing with slope here, of g of x is less than the slope of f of x. Well, the slope of g is 2, and the slope of f of x is 2/3. Well, that's a false statement because g is actually greater than, right? 2 is greater than 2/3. So, for this, it is false. Moving on to 23, the y-intercept of function g is less than the y-intercept of function f. Okay, so let's look at the the y-intercept of g. Well, the y-intercept of g is 10. Alright, that's where we begin on our y-axis. And now let's compare that. So we're saying that number is less than the y-intercept of f. Well, over here, it's also 10. So is it less than the y-intercept of f? Well, it's not. They're actually equal. Okay, it's not greater than, they're just equal. So this statement is actually a false statement. So B would be the correct answer choice for that. Moving on to 24. So 24, we're given a graph and we're being asked a question at the very end of it. Now let's read the statement. It says the graph shows a model of food energy production per person in the United States from the year starting out at 1960 to the year 2010. Okay, we're given, that's on our x-axis, right? That's on our x-axis. We're just measuring years. And on our y-axis, this is the food energy production per capita and in billions of joules. So joules is just measuring energy production. Alright. Well, looking at this, it says at what rate is US per capita food energy production increasing? Well, what rate? So whenever you deal with rate, this is what I want you to think of. So a lot of times you'll hear rate of change. Okay, rate of change is just another way of saying, if I'm working with a line, visual representation, I want to think of slope. Alright, and this is increasing. So first off, in order to find the slope, let's pick 2 points on the line. I'm going to pick over here at the very beginning, okay? And let's just go right over here at the very end. Alright, so since we want to find our slope, I'm going to figure out how much we're going to rise and run. Alright, so figure out how much we're rising. Now, we're rising 1, 2. Now, it's not 2 though. Okay, look at the distance. Right here, we're starting at 15, and we're climbing to 25. So that's a distance of 10. So we're actually going up 10. And how much are we running? Now, 1, 2, 3, 4, 5. But the thing is, we have to look at our units here. We started at 1960, we ended up at 2010. How far is those year spans? Okay, looking at that, it looks like it's going to be about 50 years. Alright. So I can simplify this, right? You have two numbers that end in 0, so you can cancel this out. So we're going to have 1/5. Alright, and this is billion joules per year. Okay. Well, looking at this, I don't see anything that represents a fraction, so not quite, but I do see this 0.2 or 2/10. Now, that's how you write 1/5 as a decimal, right? If I were just to take 1 and divide it by 5, well, 5 can't go into 1, so let's bring in a decimal, let's bring in a 0. Well, 5 can definitely go into 10 twice, right? Or 2/10. So these two are actually equivalent. A is the correct choice, right? This is the slope, this is the rate at how much this energy production is achieving per year. Alright, next one, 25. I'm going to erase this graph before we get to 25 because we're going to need it. Alright, now looking at, we have to consider this scenario, so we're going to answer questions 25 and 26 with this scenario. Now, the first one says, or let's read the sentence. So it says, Dallin is working with the function f of x. Alright, so he has some mystery line, some mystery equation that we're not quite sure, but we have this little bit of information. It says he found that f of 3 is equal to 1. Alright, now what does that mean? Alright, well, we know that f of x, well, another way of just writing that is y. Alright, well, just comparing this, what I just wrote, to what we had, we can tell that 3 is our x, 1 is our y. Okay, and reading this next statement, it says Jordan is working with the function g of x, right? That's a different line. He found that g of 3 is equal to 1. So these are very similar. The exception of this is just called f, this is just called g. So, getting to this first problem, it says the functions f of x and g of x must be the same function. So what this statement is saying, it says that since I have this statement here, that they must be the same line, they must be the same graph. Like if I were to graph this, this would have infinitely many solutions. Well, it turns out, writing this, it'll actually give you the coordinates, 3, 1. Alright, so that's where I'm going to go to the graph now. Okay, so we have an x and y axis. What this problem is actually saying, it's saying that these two lines intersect at the points 3, 1. So that's 3 to the right and 1 up. So this is that coordinate. Okay. Well, let me say that I'm just going to draw a random line. It doesn't matter. Let me say that this is f of x, right? This is the line that Dallin is working with. Well, it is possible that Jordan's line could be working at, or g of x could be on that same line. But that is not necessarily the case, right? It could be right over here, right? This could be g of x. So what this means is I could potentially have one solution, or if that g of x was on f of x, infinitely many solutions. But 25, it says they must be the same function. That's not necessarily true, right? We just found a counterexample. Okay, they're not the same line. So this means that is a false statement. Okay, whatever we have as a function, right? This is our input, that's our output. This is our input, that's our output. Like if I were to look at f of x over here, this dashed line, if I wanted to find, this point lies on that line. I could say f of, well, it looks like this coordinate, the x is 1, 2, 3, 4, 5, 6. I could say f of 6. So if I go 6 to the right, how much do I go down to get to this point? Is actually -2. So I can say f of 6 is equal to -2. All that means is I take this x, and this number tells me how far up and down do I have to get to that line. Okay, that's what this coordinate that gave us, 3, 1, really represents. Okay, so let's go to 26. We've kind of already answered this. It says the point 3, 1 lies on both the graphs, y equal to f of x and y equal to g of x. Is that true? Well, if we look at this, yeah, 3, 1 is on both of those lines. So for 26, pretty much a true statement. Alright. So let's erase this. Okay, almost there out of 33 problems. Let's look at 27. So it says, which graph models 100% growth? 100% growth. Well, first off, before I even get to the 100%, let's determine which one's a growth. A actually isn't a growth, right? It's decay. As you go further and further, increasing to the right on your x-axis, this is going down. Okay, it's kind of flattening, it's plateauing at that asymptote. D, is that even an exponential? Well, not really. It's just a straight line. So this is really it's between either C or B. Now, 100% growth. Now, typically, I'm gonna write what we have for the formula. It's y equal to, I'm just gonna put b to the x power. I'm just dealing with a normal exponential here. No initial value. Now, it's growth if it's greater than 1. Okay. And typically we find growth by how much it's over 1. Right? So if I were to have y equal to, let's say 1.7 to the x power, well, what is the growth of that? What percent is that? Well, how much is it over 1? Well, it's just 7/10. Or written as a percent, it's 70%. Well, since we've been asked, what's 100%? What is 100% of 1? Well, what's 100% of 1? That's just 1. So that's how much it's over 1. So our equation is actually y equal to, since it's 100% over 1, that represents 1, you just add it to get 2 to the x power. Okay, and that answer actually is C. Okay, the reason it's C, if you were to take some points, you know what, I'm just going to create a table for this real quick. We're going to have x, 2 to the x power. If I were to choose 0, 1, 2, 3, yeah, let's stop right there. If I were to input that into our function, input 0 for that, 2 to the first, 2 to the second, and 2 to the third. Alright, 2 to the first, that's 1. 2 to the, or 2, sorry, 2 to the 0th, that's 1. 2 to the first, that's 2. 2 to the second, that's 4, and then over here we have 8. So listed as coordinates, this is 0, 1, this is 1, 2, 2, 4, and 3, 8. Alright, let's see if those points lie on this line. And I'm confident that it does. So 0, 1, that's right over here. 1, 2, well that's 1 to the right, 2 up. We still have that on the line. 2, 4, that's 2 to the right, 4 up. So 1, 2, 3, 4. Yep, looks like it's still on the line. And 3, 8, well that's 3 to the right, 1, 2, 3, and 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So it works out that this is an exponential growth. This models the equation, y equal to 2 to the x power. Now, the higher this percentage is, the more this increases. Right over here, this is still growth, but the percent of growth probably isn't that much. Alright, this is probably a 10% growth, this is probably a 30% growth, not by much. Okay, 100% growth, 200% growth, that's going to skyrocket. Okay. Alright, let's go to the next one. That is 28. Alright, 28. A lot of words. Now, I'll tell you this. The most times I'm going to read a word problem is at max twice. Alright, the first time to get the information out. The second time to just make sure that the information I got is correct. Alright. So looking at 28, it says a lacrosse league has 10 teams. So that looks like it's an important... That looks like it's important information. Alright. Each team must send at least one player to the league's annual meeting, but may send as many as 3. Okay, so you can send 1 or 3. Really, it's pretty much your decision. Now, the statement says, holding the meeting costs the league $1,000 for the facility. Alright, so they have to put some cost in order to use that space. Plus $10 per player for food and materials. League cannot spend more than $1,500 on the meeting. Alright, so that's a bunch of information to process. Let's hold back on that. The question that it's asking us is, which inequality shows the number of players n could be at the meeting? So how many people can go to the meeting? Alright, we see a whole bunch of statements. Now these statements, when you have a variable next to inequalities like that, that just means this statement ranges from, it could be at least 10, at most 30, at least 10, at most 22. You can send 0 and 22 players, and 0 and 30 players. Well, if you look at this stuff right over here, alright, I think I mentioned this to every class. This looks like a red herring. Alright, a red herring is just a number that people like to throw at you. Additional numbers that you don't need for the problem. Alright, they're trying to see if you can read the word problem, extrapolate what's important, and use it to answer this question. Alright, otherwise, you know, they can kind of see, are you using the information correctly, and things like that. But if we look at this, we said that there's 10 teams. If the question is how many players can go to the meeting, then we do not care about the facility costs. We don't care how many dollars per player is for food, right? That's not important. How much the league can spend no more than $1,500 on the meeting. So if we look at that, we can see that here, so every team must send at least one player. Alright, so if every team sends about one player, that means the lowest number of 10 teams is going to be 10. Okay. Well, we do have to take an account for the cost for a little bit, right? We can't exceed this much. We can't exceed $1,500. Well, initially we just start out with 1,000. Alright, starting out with 1,000, how much leeway does that give me? That gives me about $500. Okay. Well, looking at that, since it does cost $10 more, you know what? Let's just divide that. So with this, just divide 500 by 10. Looks like it's going to be 50. Alright, so about 50 players. Now, the thing is, that's why I'm saying that this is a red herring, because that doesn't even make sense. All we care about is this true statement, or this top statement over here. They can send at least 1 and at most 3. So if every team sends 3, then that is 30. Okay, so which statement says that? That is just A. Alright, so all this information that we kind of worked with doesn't quite really matter. Alright, let's look at 29. It says the solution to a system of equations. Alright, we're given 2 equations over here. Is this ordered pair 2k? Alright, and it says which is equal to A plus B. Now, let's not even get to that question yet. Okay, let's use what we know about systems and solutions. So let's hold off on that. Now, this is kind of an odd solution, right? We have 2 and then we have this variable for our y. So I'm going to write x and y. You know what? It's kind of hard. Like, I don't think we can use elimination. We can't use substitution or graphing. But what if I were to plug in these numbers, right? That's what a solution represents. It represents that I have an x and y. I put into either of the equations, and it makes a true statement for both of them. So, you know what? I'm going to work with this first one. Let's have 2x minus y equal to a. Well, even though we haven't done a problem like this, I know you guys can do this. So let's just input our x and our our x and our y into this. Well, we're going to have, instead of 2x, I'm going to have 2, our x is also 2, minus y, our y is just k, is equal to a. Well, it looks like from the problem we need, you know, I need to know what a is, I need to know what b is, so how about we just solve for a? Looks like it's pretty much solved, but let's simplify. Right, this is going to get us 4 minus k is equal to a. Alright, well, we solved for a. Let's see, you know what, let's save that off to the side. So I'm going to have a equal to 4 minus k. Let's see if that's helpful. Alright, in a similar sense, let's do the other equation. So I'm going to write that one. So I'm going to put 3x plus y is equal to b. And we're going to do the same thing. All we're putting in is your x and y into this equation. So we're going to have 3 set of x. We're going to put our x, which is 2, plus y. Well, y is the same thing. It's just k. That's going to be equal to b. Alright, same sense. We want to find out what is a plus b. So let's figure out what A is. So just simplify that. 3 times 2 is just 6 plus K. That's equal to B. So I'm going to write that over here as well. So I'm going to put B equal to 6 plus K. Alright. Well, since it did ask us what is A plus B, I'm just going to write A plus B. Alright, well just substitute what we have for A. What we have for A is this 4 minus K. So instead of A, I'm going to say that it's 4 minus K. I'm going to put that in parentheses just so I know that that's where it belongs. Plus, in our B, we found that it was just 6 plus K. Alright, looks like we're getting pretty closer. So I'm going to drop the parentheses. I'm just going to write 4 minus K plus 6 plus K. Alright, so we have this statement. Looks like there's a couple of like terms. Looks like 4 and 6 are like terms, so that's going to give me 10. And negative K plus K, well that's going to just cancel itself out, so there's nothing that belongs there. So we're just left with 10. So our final answer that we had is we're using systems, right? We're inputting a solution into the system, find out what these mystery variables equal, and we found out that A plus B is equal to 10. So it looks like A is the correct answer. Alright, 30, over here it says solve for X. Actually, that's a, over here in this equation, this should be an X, right next to 3. Well, it looks like we're going to be using the distributive property, so if I were to distribute this 5, we'd have 70 equal to 25 minus 15x. Alright, and so we just distribute it, let's solve for x. So let's get rid of this 25. I'm going to subtract 25 to both sides. So 70 minus 25, I believe it's 45. Yep, it is 45. And that is equal to negative 15x. We'll almost finish. Just divide by our coefficient, which is negative 15. So we're going to have x equal to, positive divided by negative will be a negative, and 15 can go into 45 3 times. So our answer for this, the solution to this, is negative x equal to negative 3, and that is D. Alright. Number 31, almost finished. We have a function, it's f of x is equal to 5x minus 2. Alright. And since it is 5x minus 2, that's our expression, we have what is f of 4. Now, f of 4 is just a fancy way of saying, so if I write f of x, just a fancy way of writing that x, or 4, x is 4. Alright, instead of me writing out the equation x equals to 4, this is already saying that. Alright, so let me write that out over here. So we're going to put f of x is equal to 5x minus 2. Under it, I'm going to put 5x. So if I were just to compare these two, it looks like from here to here, all I gotta do is wherever I see an x, you know what? I'm just going to put a 4 in place of it. So this, in other words, that's what we call our input. Well, looking at this, I'm going to have 5. I see an x. Don't write it. Let's put a 4 minus 2. Alright, this is just arithmetic. You guys can do this. We're going to have 5 times 4, which is 20, minus 2, which looks like it's going to be 18. Alright, so the answer to this is A. Okay, if you wanted to, we kind of did a problem like this. That this is our x, and this is really f of 2, or say f of 4, is equal to 18. So if you wanted to write this as a coordinate x comma y, it is x is 4, our y is 18, right? Because that is our output. Okay, so in this problem we put 4 into a function, we chewed it up, did a whole bunch of things to it. What got spit back out is this number 18. Alright, and that is A. Okay, finally the last page, 2 more problems. Number 32 looks pretty easy. It looks like we're just finding the slope. So pretty much, you know what, just looking at the line, looks like it's a negative slope. So we can use process of elimination, just cross out A and B. So right now we just have 50-50 shot. You know, I'm going to pick this point, right? Whenever you want to find slope, pick 2 points. Let's pick 2 nice points over here. And also this one. Okay, I would pick that one, but it's not quite on 2 nice points right there. Let's figure out how much we're rising. In this case, it looks like we're going down. Going down 3, so that will be negative 3. going over to the right are running, where it's a positive 5. So setting this up as rise over run, it is negative 3 over positive 5. Alright, and that looks like it's going to be C, right? D is just a reciprocal of that, not quite. That would be if you were to take 5, put it in your numerator, take 3, put it in your denominator. You don't want to do that. Alright, and finally number 33. Number 33, I'm going to guarantee you guys will see a problem very similar to this on the test. Let me just fix this. Letter D is actually $2,000. Okay, $2,000. Alright, reading the statement before I get to the graph, it says this graph shows how the price of an item varies based on the quantity of the item that is supplied and the quantity that is demanded. So we're looking at these two lines where we have demand and supply. Alright, you know what? Looking at this, I know that this is my x-axis. I know that this is my y-axis. So typically when we're working with coordinate planes, x and y-axis, you really work with x, comma, y. Well, looking at this, looks like my x-axis is being measured in the quantity. So how about I just write that? I'm going to write quantity for x. Okay, and my y-axis, it looks like it's the price in dollars. So I'm going to write, I'll just write dollars. Okay, now let's get to the question that they want to ask us. It says, if the quantity supplied equals the quantity demanded, what is the approximate price of the item? Okay, well, we have a system right here. When we have these two lines that are equal to each other, right, meaning that they cross each other, that there's a solution, that's where we'll find that answer. Looking at this line and this line, I really want to point out that this right over here is the solution. That's where these two things are equal. Right? If I were to follow this line over here and this line over here, when will they meet? Right over there. Okay, that's where they cross. That's their solution. Now, it asks us, what is the price? You know what? Let's put the coordinate of that. Let's put, So how much are we moving to the right? Okay, remember for x, always move left and right. Looks like we're going to go 2,000. And how much are we going up? Well, it's in between 30 and 40, so it looks like it's going to be 35. Okay. Now, this coordinate, just writing what we just wrote before is kind of setting up the problem. We can tell that 2,000, well, that's our quantity. And 35, what does that represent? Well, it looks like that's going to be dollars. Okay. So what this says right here is if I buy 2,000 things, whatever they're selling, that's going to cost me $35. That's what this problem, that's what this coordinate represents. So, over here it says, what is the approximate price of the item? Well, we just found of this, the price is 35. So our answer is B. Alright, that concludes the packet. If you guys still have questions, make sure that you email me, and that is it.